Eric tonight as well. Eric Anderson will introduce our speaker. Eric is co-chair of programs. Go ahead, Eric.
Great.
All
Thank
yours.
you very much. The natural world is full of a whole lot of remarkable things, and although we as humans are an evolutionary product of that environment, there is so much we don't know about what's going on there. Occasionally nature presents us with some observations that seem rather impossible or somewhat improbable. How do bears manage to hibernate for almost 6 months without urinating or defecating? And how is it that those ducks can stand on that block of ice and not lose their feet to frostbite? These are questions that we often throw into a category called natural history mysteries. Okay? And those really are, they've got explanations for them, but they're not always very obvious nor very easily understood. Tonight's presentation is distinctly a natural history mystery. Sometime in the 1920s, the small mink-sized weasel, the American Marten, disappeared from Wisconsin due to overharvest and the fact that we had altered the environment significantly. They were reintroduced in earnest in Wisconsin in 1975, and they still survive on the landscape of Wisconsin today, but only in 2 general locations, and they are the only endangered mammal in Wisconsin. What makes it more of a natural history mystery is that right now, over in the state of Wisconsin or in the Upper Peninsula of Michigan, you can trap them legally. They are in abundant supply, and yet here in Wisconsin they are missing. Hence, we've got this mystery that's about us. Our speaker tonight, Dr. Jonathan Gilbert, worked tirelessly for the last 34 years in the employ of the Great Lakes Indian Fish and Wildlife Commission, which is an agency of the 11 Ojibwa tribes in Michigan, Wisconsin, and Minnesota that help administer the tribal rights on the ceded territory lands here. So he spent 32 of those 34 years as wildlife section leader, and he's now the director of the entire biological services of the organization called GLIFWC. He received his bachelor's degree in the mid-70s from Washington and Jefferson in Pennsylvania. He worked for 2 years then in the Peace Corps in Fiji, and then followed by 3 more years working for the National Park System in the Ivory Coast of West Africa. He got his master's at Michigan State University, then he followed up 15 years later with a PhD at UW-Madison, and he's been researching the American Marten since 1992, and obviously a well-recognized expert in the area of Marten ecology. Please help give me a warm welcome for our guest, Jon Gilbert.
Thanks, Eric. A nice introduction. So, Mushuke wa Kichikumi Winini Indigenous cause, Wabana Kian Dunjaba, Gawin and the Kandamasi, Lord Makwa Odehan, Dan. Good evening, everyone. Thanks very much for the introduction, or for the invite to your meeting tonight. As Eric said, I work for a bunch of Indian tribes, Ojibwe tribes, and so I just introduced myself to you in Ojibwe, giving you my Indian name and where I'm from and those kinds of things, the way that they would do that.
Can we hear you in the back?
Oh yeah. How am I doing projection-wise in the back there? Are we all right?
A
little more, okay, yeah. Diaphragm working.
Would you like a microphone?
If there's a microphone that helps, I'll wear one, but let's try it like this first, okay? Okay, so, appreciate the invite to come down and talk with you today about American Martens. I'll go over a little bit of what Eric talked about as an introduction. As he said, I've been working with Martens for a long time, and when he called me up, you know, it must have been, I don't know when, in the summertime to ask me to come tonight to talk to you. And he said, well, why don't you talk about Martens? And I was like, well, that's easy. You know, I've been doing it for so many years. I've probably got 20 presentations on my computer. I'll just load one up, and, you know, I can give that. Well, I don't know. Call me a workaholic or whatever it is, but I decided, no, what I wanted to do is to try to gather together all of the information, or at least most of it, that we've collected over whatever it is, 25, 26 years of doing research on this critter, and try to present it to you together, all in one place, okay? It was kind of a daunting task, you know, trying to go back 20 years and pull results out of papers and such and put them all together. I'll give you a heads up that it's not a really happy story, okay? There are some sad things about this that I want to talk about. I think when I first talked to Eric about this talk, I suggested a title that included American Marten, Wisconsin's only endangered mammal, and a conservation dilemma. So that's the theme of tonight. It's a conservation dilemma. I'm going to present to you information about the animal, its status in Wisconsin, and what we've learned about it. And then challenge you all to help me with some answers at the end. Okay? How are we doing in the back? You can hear me okay? We're good? Yeah. English. So, GLIFWC, Great Lakes Indian Fish and Wildlife Commission. I just want to start out first a little bit of an introduction. I work for 11 Ojibwe Indian tribes in 3 states, Michigan, Wisconsin, Minnesota. These are tribes that had signed treaties in the 1800s in which they reserved the right to hunt and fish and gather resources to meet their lifeways in areas off of their reservations, on public lands and waters throughout where we call the ceded territories. Here, you see the maps and the dates with the treaty signings. My job is, our job at GLIFWC is to assist our member tribes in the implementation of these rights 2 ways. Biologically sound, that is the harvest of these things has to take place in a sound biological framework, and importantly and uniquely culturally appropriate, so that the rules and regulations we develop, the way that we work with our member tribes is not only appropriate biologically, but it's appropriate in terms of their culture as well. It makes us unique. Not very many natural resources agencies have to discharge their responsibilities in a way that's culturally appropriate. Marten, Wabasheshi Dodem. Wabasheshi is the Ojibwe name for Marten. Wabasheshi Dodem means Wabasheshi is the clan animal, one of the 7 original clans for the Ojibwe people. It's the warrior clan. You can see in the middle of in here the 4 ways that the Marten clan provide for the people. The warrior clan, Ogichida. Adoption, all people who are adopted into tribes become Marten clan, Ojibwe tribes, they will say. They're the strategists and they're the providers for the village. They protect the village. Okay, they provide for them. They're the hunters in the village. So, why am I working on Martens? Well, as the tribes have these rights to hunt and fish and gather, they have responsibilities to manage these resources, to collect information, make sure that they're well cared for. Why the Marten? Obviously. Clan animal, very important species to the Ojibwe people, and it's a rare species, so it's worthy of our attention and our efforts to recover the species. Okay, now I'll do Martens. Okay. Martens, Martes americana, the American Marten. The American Marten is one of 2 Martes species that live in North America. The Martes genus is circumpolar in its distribution. You can kind of see through North America, Canada, Northern Europe, into Russia. Martens are distributed throughout the circumpolar regions. There are 6 species of Martens in Europe and Asia. 2 species of Martens in North America. The fisher used to be a Martes species. Fisher used to be Martes penanti, right? It's no longer a Martes. It's now Picania. And so they changed its genus, so it's no longer that. So Wikipedia is wrong, right? Here's a Wikipedia map, it's wrong. This has Martens and Fisher distributions on it. Not like that, okay? Martes americana is the American Marten. We know also there's another Marten species in the Pacific Northwest, in Washington, Oregon, and up into Canada. That's the Pacific Marten, Martes corina. So that animal will live in this area. I'll have another slide here in a second about that. We had a little artist draw us up some pictures of the 8 species of Martes around the world. Here they are over here. So the challenge is, can you match a name to the picture? We had a conference up in Ashland this summer with Marten researchers from around the world. 100 people came for 4 days to talk about Martens and such up in Ashland. They had a challenge, matching up those photos with the names. It's hard. North American distribution of Martes. And you can see here now we have it broken down a little better here. This is an Americana. Right? Oh wait, I do want to go back to this. Please note here, I told Eric I'd do this. Here we go, number 2, European pine marten, right? If you say pine marten, you're talking about Martes martes, the European marten that lives right over in here, okay? Marten we got here, it's not a pine marten. It's an American marten, Martes americana. So Martes americana is the blue, right? Here's the Corina distribution, the red there. Here's an Americana, here's a Corina. Fishers, like I said, Fishers used to be Martes, but now it's Bicania, different species, different genus. Important northern range limit for Martens is blue, the northern range limit here, determined by tree line. Southern range limit down here, this range limit here, determined by summertime temperatures. Get ready, folks. What are that is? Okay, so Eric went through a little bit of this, but so brief history of Martens in Wisconsin. Extirpated in the 20s. Extirpated means driven out, right? Driven out, not here present, had to be reintroduced. First reintroduction, 1953 on Stockton Island, the Apostle Islands, up in this area, right up in there. In 1987, DNR said, nope, didn't work. There are no more Martens there, okay? Let's wait till the end of the talk, we'll talk about that later. Several reintroduction events, some on the Nicolet National Forest over here, number 3, 75, 80s. You know, you can see the numbers that were reintroduced. Both heavily male biased, lots of males in that reintroduction, not too many females. Not the best thing in the world. Schwamedy National Forest, over in this area, number 2, 87 to 90, and then again 2008 to 2010, you can see the numbers there. And now this time we made a real effort to bring in females, so we have 2-to-1 ratio on females to males on that introduction. We're going to talk a little bit more about that one in a second. I do want to say that when I put the slideshow together, I had no idea who my audience was going to be tonight. And so I hope it's not too nerdy for you guys, all right? I tend to have a lot of science stuff in my talks, okay? So hopefully we don't get too bogged down and stuff, but let's see where we end up, okay? Oops, shoot. Hair sampling for DNA. You know, when I took genetics in college, I learned about Mendel's laws and kind of the colors of pea flowers. That's what I learned about genetics when I took it. I tell you what, man, genetics is a whole lot different these days than it was back then. They can do a whole lot of stuff with genetics that you could never even imagine. And so, a lot of people that are smarter than me, you know, they want to go get some of this DNA, and one of the ways that we do that is through these hair snares. So, 2 different kinds of hair snares that I'm showing here. One is this kind of a TP configuration with bait in the middle. You're going to attach the TP to a tree like that, you see it? Attached to the tree. The marten comes in from the bottom, or comes in from the top to get to the bait. It goes by these little sticky pads. You ever see those mouse trap things, you know, like glue trap things, like the most inhumane way to trap any kind of animal ever, you know? That's what they are. We're not going to trap the mice, I hope. We're going to snag a little bit of hair on those sticky pads. And then that hair there, the follicles will contain DNA. Scientists can bring them into the lab and then figure out what kind of species it is, the sex. Sometimes they can identify individuals, who's related to whom, and a whole lot of other stuff. So that's one kind of hair snare. You can see here, Mr. Marten here is walking by. He's actually hopping by. He's not defecating, I promise you. He's not defecating okay, on my hair snare, I promise you that. He's just hopping by that snare. That Marten never went into that snare. He was right there, all that nice bait. No, I never went in. I don't know why. You know, you can never figure out these animals sometimes. The other kind of hair snare that we use are these PVC tubes. Again, same idea, baits in the middle. Instead of having the sticky tabs here, instead of those, we have bristle brushes, gun cleaning brushes, right? As the marten goes by, goes into the tube, goes by the brushes, hairs are snagged, pull them out, follicles are collected, and DNA is then analyzed. So I'm going to talk about, like, this is the most recent stuff that just came out, this slide, okay? Here's where we are now, current status. We have two people that did some DNA work, one on the Schwamigan National Forest, one on the Nicolet National Forest. Got all my citations up here, so Phil Manlick, he did his work over on the Schwamigan, and Jen Gower, she did her work over on the Nicolet National Forest. And through this magic of DNA, they were able to estimate all these things. They could figure out what the population was. 40 individuals there, 132 there. That's it, man. 40 and 30, 132. Not very many, right? Lambdas. Lambdas, for those of you who don't know, lambda is a growth rate. So a lambda of 1 means the population is stationary, okay? If it's above 1, it's increasing. If it's below 1, it's declining, all right? So lambda 1.02 is like hardly anything, right? It's just staying there. You got, what, 40 individuals, and they're just staying there, not increasing, all right? Recruitment, about a female young per adult female. That's a low recruitment rate. Normally it would be up around 1 female per 1, okay? Or maybe even 1.2. Juvenile survival, look at that, 39% of juveniles survive only, so 60% of them, more than 60% of them are dying every year of the young. Got a 40% extinction probability in 50 years. This is the Schwamigan, that's this area here, right, where they're located. 40% extinction probability over 50 years. That augmentation that we did in 2008 to 2010 on the last slide, that augmentation only slightly improved this probability of extinction. We did not rescue the martens on the Schwamigan like we thought we were going to when we did that introduction. Minimal improvement only. Jen Gower on the Nicolet, she found similar results over here on this population. Similar results, a little bit different, not too much, a few more individuals. Lambda 1.16, so it's increasing slightly, okay? 0.86 female young per adult female, a little bit better, but not much, right? Look at the juvenile survival is even worse, 0.3, right? 20% extinction probability over 50 years. So a little bit better probability, but 20% over 50 years is not making me smile. Look at this one. Immigration to both Nicolet and Schwamigan of 1 female per year makes the population viable over the long term. Immigration. Immigration into these populations. Michigan has a good, like Eric said, good healthy population of martens. Immigration in. That will help these populations if we can do that. If we can make that happen. This population over here is right adjacent to it. It's contiguous. We'll have more on this a little bit later. This one is a little bit separate, and we'll talk about that also a little bit later. Two different situations there. So that's where we're at now. Let's see, what does it say? Come on, Echo. You're not going to go? There we go. So, what do we got? Small isolated populations, negligible growth rates, poor survival, especially among juveniles, creates conditions for stochastic extirpation events. This animal could go extinct or be extirpated from Wisconsin easily with just a few bad things happening to it. That's what that means, okay? We got bad stuff happening with martens there, according to that, okay? So why is that? Why is that? Why is this happening to martens? We reintroduced fishers about the same time. Fishers were also extirpated from Wisconsin. They were reintroduced a few years before martens. Fishers are doing fine. We have a fisher trapping season in the state. We harvest over 1,000 fishers a year. There's probably 5,000 or 6,000 fishers living in northern Wisconsin. Fishers are doing fine. Why is it the fishers did fine and martens didn't? What's going on? Why is that? So, some hypotheses about why. You know, what could have possibly happened? Survival, recruitment, those are the two main drivers of population dynamics. And we got immigration, emigration in there too, we'll talk about those, but mostly survival and recruitment. So, you know, summer temperatures, we talked about that already with martens. We're at the southern edge of the range. The southern edge of the range is determined by summertime temperatures. As summer temperatures increase, the range limit is going to push north. And we'll get less and less marten range within Wisconsin. That's part of the problem. Maybe it's habitat. Maybe they don't have enough to eat. Maybe there's competition or predation effects that we don't know about. So let's talk about those. Let's look at them and see. What about recruitment? What about pregnancy rates, litter size? What do we know about that? Are those adequate to sustain this population? Juvenile survival. We've already talked a little bit about that, but juvenile survival. Maybe that's not up to speed. These last two, I'm going to leave them for now. We'll talk about them. Assortative breeding and lack of immigration. I want to talk about those, but they're one of my nerdy slides. I'll have to talk about them. So, those of you that have ever been out on a trap line before to capture and collar martens. Where's my clock? 7:25 here. Okay, so let's go through these. Just some quick video pictures to show of what we go through to capture and put radio collars on these martens. Look at this, I love this. Here's the photo. Here's a line drawing that an artist did for me, the same animal. Kind of cool. So we're going to use box traps. Go out, put box traps out in the forest. We'll bait them up. We use a lure. This is a Gusto. It's a skunk-based lure. It's an attractant. Calls animals into an area. Rondo is putting it up in the tree there with their feather to attract those martens into the area. We got a box trap here. It's all camouflage. You can see the jaw right there, maybe a little bit, right? So it's all protected there, that trap. We like to set up these traps with the structure the martens like. I also like my sets to be very well protected like this, with this birch bark and all this stuff over it. Not so much to camouflage it, because the martens, they see it, they know it's there. It's for weather. So when animals are in the trap, if there's a rain event, or if it's snowing, or if it gets cold, all of a sudden, we got animals protected, they're well cared for. I want the animals that I put collars on to be healthy and to behave normally and not be stressed out because they were caught in bad conditions. There's your marten in the trap with the bait wired into the back. Working up the marten. So we'll, poke and prod and do all kinds of mean, nasty things. Pull a tooth out, we'll put a collar on, we'll weigh them, take physical measurements, try to keep them off the cold bed of the truck because they can't thermoregulate very well when they're immobilized like that. This is John Wright. John Wright was a Stevens Point graduate, worked with me for a number of years. I got his master's degree here with Ray Anderson. The collar on, take the mandatory photo. See how cute they look. Right. 30 minutes later, they're up and on their own, running away. Please do not be disturbed about this. This is not blood. Back in the day when this photo was taken, we used to tattoo them, put tattoos in their ears as a permanent marker. So that's just red ink from the tattoo. Now we use pit tags. Tags in for the permanent marker. So that's the fun part, right? Going out, catching these guys, putting collars on them, handling them, everybody takes a photo, holding them, and all of that, right? Then the hard work begins. The hours and hours and hours of sitting in the back of the truck, listening to beep, 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 beep. That's all you hear. And taking directions, plotting locations on a map, on your computer. After you do that for long enough, you begin to calculate home ranges, right? Everybody knows what a home range is. Here's a whole series of home ranges for a whole bunch of different martens that are through that study area on the Chequamegon National Forest. Ooh, look at that transition. So what do we find? Well, so here's some of the stuff that I've done. Home ranges of 3.5 to 4.5 square kilometers. It's about 1.5 to 2 square miles. Joe Dumyan, he also worked on the Chequamegon. He did about the same thing. Here's John Wright's work. His on the Nicolay, his home ranges were relatively small compared to others. Davis, what's his first name? Davis was also a Stevens Point graduate. He studied the martens after they were first reintroduced. So he was tracking martens that were just captured somewhere else and released in Wisconsin. And you can see their home ranges are really big compared to the others. Strickland and Douglas, they're kind of the go-to resources on some of these, and they just provide these ranges. Note that the males obviously have home ranges larger than females, kind of standard for that kind of this kind of a critter. So we talk about habitat selection. Habitat selection. Oh, in all my slides, I've tried to put the citation up here of the papers that I've used to where this data came from. We talk about habitat selection. We can look at habitat selection at various scales, right? So we can look at habitat selection at a really big scale, at like the range, or we can look at habitat selection at a home range scale, or within a home range scale, or some of these really site-specific scales. So we have all these different kinds of scales that we can look at home range and habitat selection. Okay, so if we look at, this is the landscape scale here, habitat selection, and what we've done is we've created these maps. The green on the map is suitable habitat, the red on the map is unsuitable habitat, the blue on the map is neutral, okay? And then we plotted, I don't know if you could see some of these home ranges that are plotted there, that are kind of a little brighter than the background, right? Can you see those? All right. So then we took the exact same landscape. This is our study area with the cover types the way we knew about them. Took the same landscape here, and here we put down random home ranges. Just plop them down randomly. And they're circles. You can see them, right? Okay. And then we compared the composition of the habitats from the random home ranges to those that were actually delineated by the Martens themselves. And what we found was that in Marten home ranges, 70% of the area within their home range is this green color, at least 70%. And in these home ranges that are random, a much greater percentage of that home range was the red color, the unsuitable habitat. So Martens are putting their home ranges in places where there's a big area of suitable habitat. The habitat is occurring in big blocks, and there's lots of it. It can't be a highly fragmented place, like some of these over here, right, in this area. Highly fragmented with a lot of unsuitable habitat. Martens don't like that. They want big blocks of suitable habitat. That's the landscape scale stuff. So if we start looking at the inside of the home range now, we look inside their home range, and we say, where in their home range are they, what in their home range are they using? What kind of forests in their home range are they using? And so we could begin to plot this information on a graph like this. So I'll take you through it here. This blue is the study area. That's this first bar, right, in each of these, is the study area. The amount of the study area in that various cover type. So for example, what do we have? About 42% of the study area is in northern hardwoods. Okay? And you can see the other percentages here. Swamp conifer, where we had about 20, 21% or something like that in the study area. Then we have the male, right? The orange is males and the blue is females. Male and female Marten use. So, well, let's look at this one. It's easier. So if the use of the males and the females is above the study area percentage, we say that the animals are selecting for that. They're seeking it out. They want that. They like that. They're spending more time there than that area is available to them. When the, let's pick one here. When the male and female use is less than the study area bar, that means these animals are avoiding that. They don't like that. They're using it less than expected. Okay? So what do we see here on this graph? We see that Martens are preferring and selecting these northern hardwood stands, and they're avoiding these swamp conifer stands. Well, that's different. They're called pine martens, right? Why are they called pine martens? Pine martens because they like conifers, right? Even though they're not pine martens, they still like conifers, okay? That's what they like, these martens. So why is it that we're finding this preference for hardwoods and the avoidance of swamp conifers? What? Hang on, we'll get to there. I'll explain that in a second. Also, after you collect these home ranges for years and years, you begin to notice things. And what I began to notice is we have clusters of animals, okay? You have clusters of animals in these, and that set up home ranges together. And sometimes these clusters of animals, there's animals there, and then sometimes they go away. And sometimes they disappear, they become extinct in that area, you don't have any more there at all. So, for example, group 3 is the oldest. Where's group 3? Here, this one. Had Martens since 1995. No Northern Martens present for a period of years. After like 2001, there was no Martens there anymore. So from 94 to 2001, we had Martens there every year. I put collars on them, I could track them. And then after that, they disappeared. And then they came back again, just recently. And they're there again. Okay? And you can see the same kind of thing happen for these other groups. the populations wink on and then they wink off. These little pockets of martens wink on and wink off. First they're there for a while, then they disappear. And others colonize that area and they're there for a while and then they disappear. Okay? Interesting. So we're looking at our scales of habitat selection, right? We looked at the home range, the bigs, home range, and we looked at within the home range. Okay, now we can look at the site-specific conditions as well, site-specific locations. And den and rest sites are critically important for martens. Den sites are where young females have young. Rest sites are where animals go to seek shelter from the cold. And so you can see that we looked at these den and rest sites in the wintertime and in the springtime. So really, really interesting patterns started to occur. We have kind of 3 different types of rest sites or locations of these sites. Underground, down low, under the snow, at ground level. Here, under coarse woody debris, so that'd be under log piles or in old stumps or whatever. And then up in trees, right? So up high, up in the trees. So if you look at it in the wintertime, 21 or 30 of them were either underground or under coarse woody debris, down low, under the snow. It makes sense, right? It's cold outside. Where is it warmer? Under the snow, subnivean habitat. It's insulated, it's only 32 degrees, you know, so it's nice in there. So these animals spend their time underground or down low. A couple in trees, but not very many. Then all of a sudden springtime comes, right? Now what happens? Things warm up, snow melts. Where does all that water go? It goes down in the ground, right? So do you think a marten's going to want to be down in that wet, cold, damp, underground burrow when the snow melts? No, they don't. They don't like that anymore. They get out of there. They move up into these trees. So now in the springtime, they shifted their den and rest sites up into these trees. So they're moving it up from down below, up to high. So first of all, look at this. Both in live trees, 13 of the 16 in live trees. We're not talking about snags. We're not talking about dead trees. Martens like live trees that have cavities in it. Look at this part of it. Minimum diameter of 52 centimeters. That's 20 inches or more. Okay? How many trees in northern Wisconsin have a diameter of 20 inches? It's rare. Okay? There are some, but they are rare. And so these large, live trees, critically important for these animals, they are becoming rarer and rarer. And so it's more difficult for these animals to find den and rest sites. We also looked around these den and rest sites and counted the amount of structure there, coarse woody debris. Went out and measured these things, and we found some are bold and some are not bold, right? Can you see it? So if you look at the logs within 7.5 centimeters in diameter, 51, what are our units again? Cubic meters per hectare. There you go, try to figure that one out. 51 cubic meters per hectare of logs around these winter rest sites, compared to, on random plots, 30 cubic meters per hectare. So almost twice as much structure around these rest sites as what you would find normally, okay? Martens are seeking out these rest sites that are in forests that have very complex physical structure. Lots of dead and down woody material, logs, snags, etc. Those are the kind of forests that they like. So just kind of a repeat of that. Martens prefer close canopy forests, dominated by hardwoods and conifer. And let's just hold on to that. Well, the next slides, we're going to talk about this part of it. Why that's such a weird conundrum for us. Forests must have adequate numbers of large trees, complex horizontal and vertical structure, and they got to have big blocks of these habitats. Forests in northern Wisconsin are not looking like this very much anymore. They're becoming simplified. The trees are smaller. The conifer component is less. There's not as much structure out there. So the kind of forests that martens prefer are going away. Not completely, but they're reduced in abundance. I don't want to say that there's none like that. It's not my point. But they're reduced in abundance and they're on a downward trajectory. All right, let's talk about this issue of northern hardwoods. okay? Northern hardwoods versus pine versus conifer. Martens are known to prefer conifer stands. That's what they like. We found that they prefer northern hardwoods. What's up with that? Why is that we did that? I got a couple of aerial photos here for you. You can see, and those of you who know northern Wisconsin, you know that it's a very heterogeneous forest. They're not northern hardwoods, big blocks like that, a wide open, just maple and such. Look at it. You have the light, these are the deciduous trees, and the dark are the conifer trees, okay, so you got that? So look at how kind of pot-marked it is by conifers all through these deciduous forest stands. Same thing over here. Lots and lots of these little pockets all over. Okay? So when we talk about a northern hardwood forest in northern Wisconsin, it has a lot of conifer in the forest, in these tiny little 3, 4, 5 tree pockets sometimes, maybe a couple of acres. When we go to the national forest, or we go to any forest management agency, they create maps. They create maps of stands of trees. And they classify those stands of trees based on the dominant tree in that stand. And so when they go to a stand and they classify it, they can classify it as northern hardwoods. That's this white. Because most of the trees are either sugar maple or basswood or yellow birch or whatever, northern hardwood trees. Okay? The dominant ones are. It doesn't mean there's no conifers there. They are there. But the stand is now called the northern hardwood stand. Okay? So when we take our points and we plop them down, here's 3 rest sites. Plop them down. Oh, look at, they're right in that northern hardwood stuff. They must prefer northern hardwood forests. Look at the aerial photos of where those points are. Right in those little conifer pockets. Okay? So the error that we made was looking at these very site-specific things, but looking at it in a very general way with a general map that was made for one purpose and not for the purpose of looking at marten habitat use. Okay? So it was the kind of maps that we were using that led us down that road that said northern hardwoods was important, when really we're finding that these conifer pockets are important. Nick McCann, he did a really interesting study where he followed marten tracks through the snow, and he plotted every one. And every time it turned, he plotted that. Every time it turned back, he plotted that again. And he plotted out these marten tracks. And so he'd come up with a data set that looks like this, of these marten tracks through space. And this whole thing was classified as northern hardwoods, this whole area, right? Classified as northern hardwoods. You can see these marten tracks that go along, and all of a sudden they come to this point here, and look how they're all mixed up, right? He's going back and forth, and up and down. He's kind of investigating all around, right? There it is, going up there. Oh, look where he's investigating all around, right there in those conifer pockets. So these animals are using this northern hardwoods forest type to travel through just fine. They can travel through it, but they're really interested in these conifer pockets. That's what they like. So they're living up to their name, pine marten. They're living up to their name as martens and their reputation for liking conifers. But they kind of tricked us there with the way that they did that. So what is it about these conifer pockets that's so special? They're hemlock and cedar, primarily, hemlock and cedar. It's not the species, right? It's not the hemlock and cedar that they like. Martens live all around North America, lots of places where there's no hemlock and cedar. And so they live in forests where there is not this species. So it can't be the species that are attracting them there. So what we did is we went and we looked and we started counting things like what's the tree density? How many logs are there? How many snags? How many stumps? And you can see the blue bars are the hemlock pockets. Blue bars higher than orange bars. More structure, more of that stuff that martens like in those hemlock and cedar pockets than what is found in the northern hardwood stands. Over here, these are decay classes, so this is like sound wood, all the way out to here. These are like really rotten logs, okay? And you can see in the hemlock and cedar pockets, much more of that decayed material, the stuff that they like to live in under the snow, keeps them sheltered from the weather and such. So, reasons why they like those things: structure and these rest sites and den sites that are available to them. That was habitat. Mortalities. So remember we talked about survival, mortalities. So, like it says, they're never fun, but they tell you a lot. So we walk in on a tree. So our collars, they change when the animal lies still for more than 6 hours. It changes from 1 a second beat to 2 a second beat. So instead of beep, 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 it's a beep, 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 right? Double. So you know something's wrong. The animal's probably dead. So you walk in. They never die real close to the road. They always die far away. You walk in, and so here is this dead tree right here. Thought the animal was in there somewhere. So we cut it down. Here it is laying down on the ground. Right up at the top is where we found the animal. So we cut the top of the top off there to kind of locate it. I got another picture here. Here it is in there. So here's the top where we cut off. Here's the top of that snag. Here's the marten. You can see the antenna. You can see his collar there. Right, he's stuffed in there, right? So he's stuffed in the top of this tree. Wasn't eaten. He was just stuffed in there like that. So you begin to wonder why, how, what happened, you know? So in order to help us identify that, you can thaw him out and do a necropsy on him. You can see then, we cut him open and look. You can see here's the head, down the back. Obviously, this is where he got hit, right? Killing blow to the back of the neck. It's an obvious mammal predation kind of a killing blow, right? Where he's just got his neck crunched. So up in the tree, mammal predation, we're thinking probably Fisher killed this animal. So you go through the thought process like that to try to figure out what killed these animals. Never fun to lose an animal, but they do tell you a lot. Remember we talked about juveniles also, and juvenile survivorship a little bit? We don't have any data on them because it's really hard to put collars on juveniles. And so I went and I looked at some information that I had, and like right here, this is just the average age of the martens that we've caught during these years, some time ago. Over 3 every year, over 3. Strickland and Douglas, remember I told you they were the gurus? They looked at 2,700 martens. 90% of them are less than 3 years old. So we have an old population, that tells us. Okay? Look at this graph here. So when I go out and I trap martens, I age them and I can tell how old they are. And most times when you trap martens like that, about half of the animals you catch should be juveniles. Okay, because there's a lot of young animals out there, so when you catch them, most of them should be juveniles, half of them. So here's again the same years. Here's how many martens we caught, the blue bars, right? Here's how many juveniles we caught that year, and this is the percentage. So between, well, 0 and 20% of the animals that we're catching are juveniles, whereas it should be up around 50%. That's an issue. You don't have juveniles, you don't have a good population. You can't grow if you have no babies, right? So I don't have good information on fecundity and juvenile survivorship, but I have some incidental information like this that tells me that there might be a problem. But we don't need to go through all of this. I've talked about most of it. The only thing I'll point out here is predation is a major cause of mortality. Fishers kill martens, kill them in the wintertime. Raptors kill martens, kill them during their kit rearing time, in the springtime. 2 sources of mortality. Juvenile abundance, far less than expected, perhaps due to excessive mortality of juveniles. What happened here? Okay. Food habits? What do these guys eat? So we went out and caught a whole bunch of animals, collected their scat, washed it out, looked at it under a microscope. Did you know that every hair of every mammal has a unique pattern in its hair? And that you can identify the species depending on the pattern in that hair follicle? And so that's what we did. We went and we looked at all these hairs in these marten scats. So, some surprise here. 38% of what was in marten scat was from a shrew. Shrews, really? Shrews are yucky. They don't smell good. They eat yucky food. They don't taste good. At least I don't think so. You know. 30% from deer. So we had the top 2 shrews and deer. We had 4 of them that were about mid-range here, with voles, birds, peromyscus, red squirrels, and then less than that, you know, incidentals. That's interesting. Deer and shrews, they have major food. We also can look at foods in terms of what's called an isotopic analysis. where we look at the isotopes found in animal fur, and we can surmise what they eat. I'm going to just go a little faster, because of course I'm running out of time. So, through this isotopic analysis, we can identify, here's where carbon and nitrogen are the two isotopes. Here's where the large prey, grouse and deer, would fall out. There's shrews and mice in this area, flying squirrels, red squirrels, wolves over here. These are the martens, okay? So they're pulled up. They're mostly up in this large prey, small prey. So again, we knew that, right? Deer and shrews are the top two. Pulled over this way a little bit by some of these. This isotopic analysis is kind of cool, but it's really, really hard to interpret very well. So up here, for example, tells us they could be eating mice or they could be eating shrews. Now, mice, that's good food for martens. That's what they normally eat. Shrews is not. So why did we say shrews more so than mice? Well, that's because in that food, in the Scat analysis, 38% of what we found in the Scat were shrews. So we surmised that, they must be eating shrews up here instead of mice. So if we look at this graph here, so these two bars, the first two in the graph, are from another study in Canada. Okay? And we had a lot of prey for the blue ones and only a little bit of prey for the green ones. And you can see when there's a lot of prey, they concentrated on redback voles, hares to a certain extent, but hardly any shrews, right? Then when the prey was reduced, they shifted, and many more shrews were taken. Okay, much fewer redback voles, okay, because there was less prey. Look at where Wisconsin is. For their shrew component. Way, way high compared to those others. It's not a good diet. It's maybe indicative of poor food habits, poor prey availability, resulting in animals that are starving to death, juveniles not surviving. What's that? Oh. I can talk about all that anyway. All right, so we're almost done. But now we're getting to the really, really nerdy stuff, so I have to apologize for this. All right, so this is genetics. Genetic structuring. So here's our Schlumberger population, here's our Nicolay population. We looked at the genetic structure of the animals in these populations. And we found that they are unique, that the ones over here are unique compared to the ones over here. The ones over here are composed of these red primarily, red up here. This red is the Minnesota releases, okay? These over here are composed primarily of the green. The green is from the Michigan and Ontario populations. Ontario is what source population here. Michigan is adjacent, coming in. These animals, after 30 to 40 years, are maintaining the genetic signatures of their source population, where they came from. They're not interbreeding with each other. They don't seem to be breeding with each other. Minnesota Martens don't like to breed with Michigan Martens. You know? Don't ask me why. I'm just saying that's what's happening here, it seems like. So we have this effect called assortative breeding going on, where this genetic structuring is maintained. Martens are not breeding with members of other genetic groups. And Bronwyn Williams, who also did the same work up in the UP, she found the exact same thing. Highly structured population. Martens are not interbreeding with each other. Really, really interesting. The last thing I'm going to talk about quick is dispersal. So this is up in the Schwamigan population is here. Here's Michigan. This is Iron County. That's what this is. And so Casey Day simulated dispersal through this Iron County area. And what he found was martens could not disperse through there. That due to starvation or predation, they never made it to the other side. You can see, after even 5 generations, they're over to here, they still haven't made it to the other side. Having a very, very difficult time dispersing through that Iron County area. And remember what I said about Jen Gower? Remember Jen Gower? She determined that if we have 1 female immigrant per year, we can rescue these populations, right? But if we can't even get through from Michigan over to Schwamigan, this dispersal pattern is the same going the other way. If you can't get through, how are you going to be able to rescue this population through this immigration events. That's what we want. So some of our management objectives should be to improve this area so that Martens can make this crossover from Michigan over into Wisconsin and provide that immigration event that we know will, or we hope at least, will rescue these populations. What if these Michigan Martens over here are from Ontario? And then we get them to disperse over here, and now they're over with Schwammerton National Forest Martens that are from Minnesota. And we have a sort of a breeding effect going on. Are we actually doing anything? Will we actually help by doing that? It's a really interesting question. Last thing, competition and predation with fishers. We're going to do this kind of quick. Here, this is a historical situation where we had conditions of old growth, conifer forest, deciduous forest, large prey, small prey, and snow cover, kind of deciduous or historic conditions. We had martens that used more old growth and conifer and more snow cover, and fishers that used more large prey and deciduous forest. And so they separated out the fishers and the martens that didn't overlap so much within this niche space. That niche space has been changed over time. That's what I was saying before. It's now more like this, where we have lots of deer. We still have snow cover, a little bit less. Old growth is almost gone. Conifer is less. Deciduous is less. So we have this compressed niche space. And now look at the overlap between martens and fishers, almost identical, right on top of each other. We know from our theories of lacto-volcarum models that when two animals compete strongly, only one can survive. They cannot both live. One will die out. So the superior competitor is going to predominate. So we're pretty sure that fishers are the superior competitor. So predation, competition with fishers, it's not also looking good for martens. As I said, we have lots of fishers around. I want to zoom through these really quick. This is the good news part of the story on the Apostle Islands. Remember we said that they were extirpated in the 20s, the 50s. They were introduced out onto Stockton Island here, this island right here. Okay, remember that was the one that DNR said in the 80s failed. Okay. So a little bit of a history here of what we've seen. In '64, they went untrapped out there. They didn't catch anything. That's when they said that probably didn't work. 1969, there was one marten observed on the ice near Stockton Island back in '69. 1970, that's when the Apostle Islands became a national lakeshore. Since that time, there was no martens ever seen there until 2010. Okay, 2010, there was a picture was taken of a marten on Stockton Island. 40 years after the last sighting. Okay, really interesting. 2011, martens detected in Redcliffe right here. Okay, start going. I'm sorry, say it again, go ahead.
I'm curious why Stockton was selected, and I am aware that there are campgrounds on Stockton now as well.
My guess is Stockton was selected because it's one of the largest islands.
Okay.
The other islands are pretty small up here. So since that time we went out, we collected Scat, we looked at photos and all that, put cameras out, and you can see that now we got 14, we got a marten detected on Manitou Island. That's this one right here. Then 2015, we got cameras on several islands, including Stockton. Look at this, 2 martens at a time, pretty nice. 16, they deployed cameras again. Now we have martens on 6 islands. Cool, huh? Nice. So, we're almost done, I
When they swim, or would it be over ice?
That's a good question. Why is this not working?
On board?
It was working so fine for a while. Oh. To continue, you need to log on using an administrator account. There we go. So again, DNA, magic DNA stuff. So we collected Scat from some of these islands. You can see Stockton, Manitou, Michigan, Rocky, Aldo, Otter, Raspberry Islands, all have Marten scat on. How about that? Pretty cool, huh? So we went around and got some DNA from Montana, British Columbia, from various comparisons. So here we can see where the Martens are found here on these islands. Look at this population estimate for Stockton now. We got 16 Martens on Stockton Island. How about that? Huh? Manitou 6, Cat 7. How about that? We have almost as many Martens on the Apostle Islands as we do as the Schwamigan National Forest. It's pretty amazing, huh? So here's some cool things. So parentage, one Marten on, I think it was on Stockton Island, was tracked to his parents, her parents, his or her parents came from Iron County. Okay, so somehow they got from Iron County over in here, up through Bayfield, out onto the islands. Pretty interesting. Also, in our look at the DNA of the genetic structure of the Martens out here on these islands, it was very much related to that 2008-2010 reintroduction on the Schwamigan National Forest. That will be down here, okay? About 40 miles or so from the islands. So what we're thinking is that these animals, some of them were reintroduced down on Schwamigan, moved up, got to the islands, got out, probably over the ice, I think. I would rather think them going over the ice than swimming. You know, it's kind of cold water, it's kind of a long distance. Over the ice out to the islands, and now we have this population of Martens out on these islands. It may be the last refuge of Martens in Wisconsin, who knows. So just kind of a concluding thing. Warm summer temperatures, reducing suitable range of wood in Wisconsin. We got small isolated populations, some connection with Michigan, but only on the Nicolet. Poor connectivity through Iron County, right? No dispersal there. We have this whole issue of assortative breeding and genetic structuring that's facing us. Habitat simplification with the role of logging and reduced structure in these forests. Poor diet composition with the predominance of shrews, right? They don't have good food to eat. Poor recruitment of juveniles, they're dying young, not mating. Okay. Predation, competition with fishers is increasing. Got problems there. All right, there it is. What do we do? What do we do? You know, Wisconsin's only endangered mammal. We throw up our hands and we say, oh, look at all these things going against it. We throw up our hands and we say, it's a lost cause. Why spend all this money? People ask me, why spend all this money to study this animal to death? You know? It's kind of depressing a little bit. I spent 26 years of my life studying these animals to see what's happening with them. Maybe Apostle Islands, last refuge perhaps, okay? But we have problems here, right? We have a lot of problems with Martens, so it's not an easy fix. We'll continue to work on it. I don't know. I'm now 10 minutes over. Eric, sorry about that. 10 minutes over my time.
Not a problem.
I would be happy if anybody has any questions, please. Let's have a little conversation if you'd like. I'll be happy to answer any questions. Otherwise, you guys have been a really great audience. Thank you very much. Appreciate your attention.
Questions?
Yeah, I have a question. So, has anyone looked at the diet of fishers? Because we've done a little bit of diet analysis on ermine that were just opportunistically trapped in the state, and they eat a lot of shrews. And we were looking at it from a disease perspective, a parasite perspective, and so the ermine have a nasal worm that is they probably get it from eating shrews. So that was our conundrum, was like, wow, how can we have 97% nasal worm infection in these ermine? What are they must be eating shrews, was our, because that's where they would get it. Sure enough, a lot of their diet was shrews. But now I'm wondering if it's because other things aren't available, or why are they eating these shrews?
Why are they eating these shrews?
And it's predisposing them to getting this
So
parasite.
the one thing I think about a little bit on that is, so you notice also deer was an important prey item, right? So they're scavenging deer, obviously, right? They're scavenging deer. So dead deer out in the landscape, what else is coming in to eat on that dead deer? Probably shrews. So are they like chomping on these little shrews saying, no, this is my deer? Maybe, I don't know. But the fact that they go together like that makes me think about things like this. So you have data that kind of shows you one thing, but you got to think about it sometimes to make sure that you're really thinking about it correctly. Fisher diets, yes, but We have some information on that. No shrews.
They don't eat
They're eating
shrews.
bigger things, right? They eat deer, hares, skunks, raccoons, those kinds of things, beavers, that kind of stuff. There's another question. Yes, ma'am.
What's the lifespan of a marten if it survives?
Lifespan of marten. We caught a marten once on the Nicolay that had an ear tag in it. From the original release, it was 12 years old. It had hardly any teeth. The teeth were almost all gone. I don't know how it's lived out there. But yeah, 12. So probably 10 to 12 would be lifespan. You know, you can see the average age was 3.5 or whatever, so a lot of them died before that, but some can live that long.
What's the reason those martens can't go from the Schwamigan to Michigan? Is it like a different type of forest? Or?
Well, that's the whole question, right? Why is that? Our modeling suggests that it's predation and starvation, so they're not finding food, and they're getting eaten by things. So those forests that are in Iron County don't have enough food for them and have a lot of predators available. What it is that we can change over there, that's a hard question. I don't know. It is a different forest than Schwamigan, for sure. It looks different. Yes, sir, in the back.
There's a declining insect population.
A declining what? Insect population?
Right.
You're out of my bailiwick, man. Sorry. I don't know.
Do mice eat them? If that's what they, what eats insects? And if there are not as many insects, then that population is
Yeah, I was
declining.
just reading the other day an article about declining insect populations worldwide and such, and it's a real big issue. Frankly, it's not anything that I know very much about at all. Yes, sir.
What's the size difference between a marten and a fisher?
Okay, martens are about 1.5 to 3 pounds. Okay. Female fisher will weigh about 5 to 7 pounds, and a male fisher will weigh about 10 to 15 pounds. So fishers are quite a bit bigger than martens. Males are bigger than females, and especially in both, but especially in fishers. They're really different like that. Other questions? Eric?
Jonathan, why if this is happening in Wisconsin, isn't it happening at the same latitudes in Minnesota and the Upper Peninsula?
Well, so first of all, Minnesota goes quite a bit further north, right, back up into the boreal system. That's where they're more secure. It's away from the edge of their range, so it's different there. Michigan is a different story. Why is it in Michigan that they're doing well, Wisconsin not so? The UP is really a different place than northern Wisconsin. It's got a lot more conifer, a lot more cedar, a lot more hemlock. We're getting further east, so that hemlock range, we're getting more into the heart of the hemlock range. So habitat conditions are really different in the UP of Michigan than they are in northern Wisconsin. That may have something to do with it. We always like to say it's habitat. That's always the reason. That's because we don't know anything about habitat. So it's
Well, Jonathan, I'd like to thank you very much for coming this evening, and I think you'll stick around for a
I'll
few
stick
minutes
around if
people have
you want
more
to sit
questions.
and chat for a while. I'd be happy to do that. Yeah, thanks.
I do have one quick announcement. Go ahead.